MongoDB and its introduction. MongoDB is actually really great, and I'm going to tell you why. So it's actually very flexible and it's free, meaning it's very free and flexible in how it approaches things. We'll take a look at SQL, NoSQL versus SQL, MongoDB, documents and collections. So SQL versus NoSQL. So SQL database usually is very structured. NoSQL is kind of like that graph there. It's going everywhere. It's very dynamic. So NoSQL, if you can look at the SQL databases, as you know, they're relational. You know what? They're very. If you have in a financial institution or some type of financial software company or these kind of things, they're going to use SQL Server, Oracle, relational design because their data structure is so specific, very rigid, with lots of different types of relationships. It's not very not really geared towards, say, NoSQL. So there are not one is better than the other. Each one has different applications to it. Obviously, one's more new than the other, but they all have their own merits. And relational databases have been around for a very long time. So SQL databases are primarily called those relational databases because they have relations, right? They have primary keys, foreign keys, these kind of relationships. NoSQL are non-related, so they're very distributed. So if you look at the graph there, you'll see a graph, document, column family. They're very distributed, right? They're kind of unstructured. So SQL has a very rigid predefined structure. SQL Server has a dynamic and unstructured for unstructured data, right? A column may be an active column, may be true false. 1 minute it may be 1 or 0. The next minute it could be something entirely different. It could be, I don't even know. It could be foo and bar, or it could not exist at all. Like it's so dynamic on each record, can be very different. And you know what? The relational database can't handle that because every column needs a type, right? So it's very structured. SQL servers are vertically scalable. You add more hardware at it, right? You add more CPU power, whereas NoSQL database can be horizontally scaled. More servers, you can scale the whole database across all the servers. So SQL servers are a very good fit for complex queries, financial reports, financial forecasts, very complicated queries where you have a designated Oracle specialist who sits beside you who only talks about being, extremely good at his job. Actually, that guy was very good at his job, to be honest, and you know who you are. and they write the complicated queries, right? Where NoSQL, it's not so much because there's not even joins in NoSQL. They have a different way of doing inner joins, but it's not what you would expect. So on the right, I don't know why I reversed it here. It should have been NoSQL against SQL to keep up that slide. So as I mentioned, SQL relational is very good for enterprise, uh, web, mobile type applications. Again, financial, where it's very consistent. And the structure's matured. It's stable. It's not going to change. You got guys who've been working on the database for 20 years, and you're not going to be able to get some schema change past them, right? If you need to go to production. Whereas NoSQL is kind of the more current stuff. I wouldn't say it's cooler, but gaming, Facebook, IoT, mobile games, Twitter, all that stuff. It's because there's lots of data. It's big data, and because of that, it's very scalable. You need to scale across a lot of servers. Schema-free, flexible. Limited queries, right? The queries are not by joining relationships. The queries are nested inside of the object itself. Very different approaches, and it's emerging technology. And it's concept of document database. So again, we're looking at this old school kind of relationship, relational versus non-relational. So the relationship is highly structured in a table, right? As we all know, this is what feels good if we've grown up in that. Whereas the document model is very, very, very big departure. So a collection of documents can have nested documents inside of it, and you may have nested documents inside of that, and the nesting keeps going. So in a way, it's like a filing cabinet, and all of the required pieces are inside of the filing cabinet, whereas you need to build those, those files with a relational database. So it doesn't incorporate the data model. It incorporates all the data can be stored in a single document file, a single container, whereas relationship databases organizes the structures and fields into defined columns. A real-world application, there's probably many like Uber, but Tinder itself, you know what? It's huge data. 1.7 billion ratings per day, which translates to 25 million matches, and they have 1 million apps installed per week. So Tinder is based on geolocation, resulting in complex database. Databases need to scale. They use MongoDB via AWS, Amazon Web Services, and Node.js. So if you know Node.js, you know that that's what it's doing as well. Node.js is used for Uber as well. With Mongo, prototyping very easy, scaling is very easy, but maintaining that across a very distributed architecture, across many servers, they had to get the best consulting firms to help them out to do that. And you know what? Hey, does Tinder work? I don't know. It's kind of after my time, so does it work? You tell me. All right, welcome back. Oh my God, I'm getting a little bit of feedback here. Hold on for a second here. MongoDB and its shell. All right, did you hear that? I actually answered my own question. That's actually kind of like a blooper there. I asked my own question, and I had another video I had just filmed, started playing in the background, so it looked like I was having a conversation with myself. So I'm actually not gonna edit that out because it's actually kind of really funny. So I'm gonna leave that in there. Why not? It makes for I don't know, makes for a better video, to be honest. I should do that more often. I can have a conversation with myself while I'm doing this. All right, so back to maybe stuff that's not as funny as that, but MongoDB, document oriented, NoSQL database, JSON-like documents. So the point to this is across the MERN stack, we're using JavaScript all the way through, and this database is going to produce a JSON document, which is really great because we can use that. It's what we all understand through all these layers. Again, it's highly performant. When indexing support is used, a natural fit for Node.js and Express. Yes, a natural fit for MERN stack, which is what we're talking about here. Of course, you can use MongoDB as a backend for any other type of platform like Ruby on Rails, .NET, all these kind of things. Again, but we're talking about JavaScript, the whole JavaScript kind of stack. And this is what we're aiming towards, but just know that it can be used across other platforms, right? Wherever it needs to be. Use JSON for queries, right? When we're writing those query languages, and we'll show you in a little bit that you can actually use different things like the native Mongo drivers and the operators, and it's a JSON object that you're querying against. You can use something like Mongoose, a wrapper, to also use some JSON queries. Again, there's no table joins. They have a way to do joins, but it's not what you expect. So if we're continuing on, again, just some high points here, what it is. We already kind of established this: high performant, built for speed, rich document-based query. So it's easily reliable, high performance, high availability, easily scalable. So we talk about auto sharding, what sharding is. It's very interesting, actually. And this thing is it's types of databases partitioning that separate very large. I can't even write a sentence here. Types of database partitioning that separates very large databases into smaller, faster parts called shards. That makes sense to me. So you can shard a bigger database and partition it across multiple servers. So very scalable, which is very great. Like we established that old SQL Server or Oracle can only go on the same server by adding CPUs. We can do the sharding. I know Oracle can do this too. The guy who's sitting next to me, the specialist, told me so. So I'm going to trust him because he was a specialist. And anyhow, but just know that you can scale it really good. If you notice in this picture, it's 1 terabyte collection. Now we're breaking it across 250 gigabytes. So Mongo recap. So SQL was invented in the 70s by a bunch of guys who are probably older now, right, to store data. And MongoDB stores objects or documents. Today, everybody works with objects. We work Python, C#, Java. We know what an object is. It returns an object. We're good. We got a good kind of handshake going on. We got a good deal going, right? I'll give you an object, you send me one back. It's great. So we need to Persist our objects. Why not store them as objects directly? Why not? You know what? I saw somebody storing objects, JSON objects, one day in a SQL server before all this stuff took off. I thought it was the weirdest thing ever. I thought it was so strange, but then I realized we were writing a JavaScript application. It was in its very beginning, Angular 1, and it all worked beautifully. I couldn't believe it. But that's why we do it. Embedded documents and arrays reduce the need for joins, right? So Mongo doesn't have any joins. It basically does nesting. So you can imagine you have, if you look at this here, you have relationship data. I'll even use my pointer here. Why not? I got a pointer. So I have a pointer here. This is a relationship database. We have articles and we have comments, and they have some relationship towards, maybe a foreign key and a primary key, whatever, what have you. But if you notice, this document is one giant container, and one subdocument has a title and all the comments inside of it. So there's no need to join it. It's all there. It's nested in nested arrays or what have you, but it's all part of this one container or document that floats around. So you don't need to actually worry about that. So the real thing is, it's really great for real-time data. So like gaming is really great because it changes on the fly and needs to react, right? So MongoDB versus SQL, we can keep going on that thread and keep going. I mean, again, it's relational model. We already kind of spoke to that, where we have table 1 and table 2, and this happens a lot. You'll actually have like an intermediate table that joins the two. You see that a lot. That's a pattern. So the document model is a collection of things. You don't need to do that. It's all in one container, and you can have multiple connections created on the fly when referenced for the first time. So mappings, just quickly to recap if we didn't already do that. So on the left side, we have a relational database, a database, and database. At least we can agree on that. They're both databases. All right. Tables are collections, rows are documents, and columns are fields. So that is the mapping. When we're talking about that stuff, you need to know that. And you'll get used to that. Sometimes you get confused when you're talking about collections and documents. Just know you're talking about tables and rows, and then what you're selecting or projecting on is a field. Document versus table. So again, we're talking about this, but let's look at it though, because you can see some bigger data here. You have a person with the phone number, and here you need two different tables here. And again, the phone number person could have multiple phone numbers, but you need to have these foreign keys floating around, and you need to type and all of that. So if you look on the left there, if we look again, let me use my laser pointer because I have it. If we look at this here, it's a little bit encapsulated here. We have the phone, but then we have an array. We don't have any keys or foreign keys. We just have a type, the home, and the work, and it's all in this one document, instead of having these two separate tables and having to manage this relationship here to join those up. And then if you notice, the next, and this is what's great about it, is the next documents in the collection don't even have a phone number. They don't even have a relationship. It's not even there. In fact, they don't even have it. It doesn't exist. They could have an email that could be true false for all that cares. Again, it's changing on the fly. They could have a phone, but it could just be something entirely different and then change back to this. And that's the power of this thing, is that it can actually change on the fly. So let me get rid of I'll keep my laser pointer here as long as it doesn't affect anybody. So queries are expressive. So here's an example. Find all contacts with at least one home phone number or hired after this certain date. So as you can see here, we explicitly have select statement, which we all remember. Select a bunch of columns from a left outer join. Geez, I even forget that, the left outer joins and what that looks like. Look up a Venn diagram. They got a really good thing on Google there of Venn diagrams to show you what these kind of joins are, and they color them in. It's really great. I recommend that for visualization. But if you look at the MongoDB, it's basically using those built-in operators. So you do, instead of doing that, you're very expressive in saying, I want the context I want to find. Then I have a JSON object where I establish the OR. So already I'm selecting everything by default. And then I have my OR, my condition, my filter, or phone types are home. So I'm taking care of this where clause here, or the higher date is greater than this date, and that's what I'm focusing on. If I wanted to do the same thing, I could also add some projection on some fields to only give those kind of fields. But if you notice, there's no join. So it kind of is very, you can do a lot of chaining, and it's again like they're trying to note very expressive. Documents and collection. I needed a little bit of a break here, catch my breath, and I can just pause it and come back. And just like that, you didn't even know. You didn't even see me. I just left and came back. All right, so a document. We already know what a document is. We're already talking about it. We're just trying to just drive it home. A document in MongoDB, if you notice the JSON schema, it's just a JSON object, right? It's like an object literal. Treat your data more like objects. So your objects are datas. If you notice here, we have a people array, and inside of this is a collection of documents that have, again, sub-documents of phone numbers. And if you notice, in the second one down here, again, let me grab my laser pointer. The phone number is part of this first one, but if you notice, the phone number is there still, but we have two new fields, home address and hometown. Email address and hometown, which is not present up in this one, and Mongo accepts it as it is. It doesn't bark, it allows anything to change. It's very accepting to the data that's coming in, which is really quite amazing. And it allows for like these great big real-time apps, and something like Uber that has, trillions of records and data coming in and changing all the time. Again, very bad for something like maybe a specific kind of financial forecast, but there's two different approaches to those kind of problems. A Mongo collection, again, is the equivalent to SQL Server table. Schemaless contains documents. Indexes, this is what's new here in the slide, indexable by one or more keys. They're created on the fly when referenced for the first time. Capped collections, so you can cap the collection. Fixed size or older records get dropped after reaching the limit. You can control it and cap some of this stuff. I think this is the last slide, I promise. Mongo document, cross my fingers, is the equivalent to the SQL record or row. It looks like this, right? The document stored in a collection as a row stored in a database can have IDs, and they work like primary keys in SQL Server. So the ID is always going to be there. It's going to be generated by Mongo when you delete it. And a key thing here is the document storage is called, I'm going to call it Bison, like binary form of JSON. So that's the storage. If anybody mentions that, that's what it is. And that's my last slide. So what we covered here is we covered MongoDB. We covered, what did we actually cover? We covered MongoDB. We covered NoSQL versus SQL. We covered the documents and collections. And what we're building towards is we want to just give an introduction of what it is. And next we're going to actually talk about the Mongo shell, interacting with the shell, interacting with various other kind of user interfaces like Mongo Compass, and some other interfaces to query against it, and also mention that we can also host the database not only locally but in the cloud in Mongo Atlas. So this is the introduction. We're going to dig into a little bit more in the next video. Thank you.